To attempt the question above, we'll be making use of the formula that says moles equals volume divided by amount at s.t.p. So what we are doing here is to determine the number of moles of the gas. So and meanwhile, the question is that we should determine the relative molecular mass of the gas, but we are still coming there. But the first thing we want to do here is to find the number of moles of the gas itself before we then proceed to determine the molecular mass of the gas. So here we are given the volume of the gas and we are given the amount at s.t.p. The amount at s.t.p is also referred to as the gram molar volume of the gas. So substituting the values, moles equals the volume of the gas, which is 500 centimeter cube, divided by amount at s.t.p, that's 22.40 dm cube. So I'll be converting from dm cube to centimeter cube, and that will be 22,400 centimeter cube. How do we get about that? Multiplied by 1000. 1 dm cube equals 1000 centimeter cube. So yeah, I'll just say to divided by 22,400 centimeter cube. Calculating this, I have 0.0223, the unit moles. So this is just the first part. Then let's go back to the next one, which is determining the relative molecular mass of the gas. And to determine the relative molecular mass, I will say molecular mass, so apply the formula molecular mass equals mass divided by moles. So here we've been given the mass in the question and we've just calculated the number of moles of the gas. So let's go ahead to substitute the values and then get the final answer. So the mass is given to be 1.58 and the moles we have 0.0223. So calculating this, we have 70.8, the unit in grams, then approximately we'll be having 71 grams. This will be serving as the final answer. So with this, we've come to the end of the solution to the question and we've gotten the relative molecular mass of the gas to be 71 grams, and that will be all. Do like to subscribe for more if you find this video helpful.